So our first topic today is solving trigonometric equations. So for this lesson, you will need an understanding of the unit circle, so just knowing the x and y values and where they line up with the pi values and all that. Another thing that you will need to know is the relations between the identities and how they actually compare to each other. So for example, the first one, sine, that is y on the unit circle. Cosine is x. Tangent is sine over cosine, or y over x. Cosecant is 1 over sine, or 1 over y. Secant is 1 over cosine, or 1 over x. And cotangent is cosine over sine, or x over y. That's all you. Get in there, Chip.
Thanks, man. Okay, so this is our section 2 questions, and our first is cosecant squared x minus cosecant x plus 9 equals 11. Now, one thing you might want to do, you might think is, oh, here's this 9, here's this 11. I'll move this 9 over here. What you actually want to do is, for this, you want to get everything onto the left-hand side. So, and you do that by subtracting the 11. So that gets you cosecant squared x minus c(x) minus 2. Now, once you do that, this is where it gets a little bit tricky. You might see this is kind of familiar. This is, you would factor this. You would turn this into, there's your parenthesis, here's your other parenthesis, and then parenthesis. So you know that you have you can kind of think of these cosecants as x's, so x squared minus x minus 2. And then you'd have to know how to do that. So you know you have two cosecants, so you know cx is here, you know there's one here. And then cx, you know there's one here. So now we need to find what goes next to those. So we know, because it's negative, what is in the middle is negative, so we know at least one of them has to be minus, and then we know the other one is going to be plus. So if you basically think really hard, you end up figuring out that it is a 2 and a 1, because you want the middle to be negative, so you know that you need to have more negatives. And then if you do this, they add to 1, which is your negative 1 right here, that's your negative. And then they multiply, negative 2 times 1 is negative 2. So once you have this, this is set equal to 0. And then after you do that, you have to solve these independently as you would a normal factored equation. You would do CSCX equals 2. And then you would solve this as well, and then that would be negative 1. And these are 2 of your solutions, kind of. We're not quite done yet. This CSC, you need to change to 1 over sine equals 2. And then what you do from there is you would multiply the sine over, and you would get 1 equals 2 sine x, excuse me, there's a x there. And then from here, you would divide by this 2 because you want that away from your sine, and you would get 1/2 equals sine. And then your other answer, you would need to do this for the negative 1 as well. You do 1 over sine x equals negative 1. And then you would do the same step. You would multiply the sine over. 1 equals negative sine x. And then your final step would be to divide by the negative 1 to make the sign positive, and then you get negative 1 equals sine x. This is a quite long and convoluted problem. So these are our 2 y values, which are our correct answers for this question. And so we need to find all of the y values which fit this. So all of the y values which are equal to 1/2. So if we look on our unit circle, we can see that this is a positive 1/2, so 150 degrees is a solution. It is not going to be down here because we know all of the y values here are negative. Then our other one would be 30 degrees here. And then for our -1, where sine is -1, we know xy. Here is our other solution at 270 degrees.
You want to put that in radians?
Not really.
Okay, well, that's fine too.
Okay, so for the next question, we have -2 sine x equals negative sine x times cosine x. Now, this is our medium question simply because of how confusing it can be to start this problem. So what I had originally thought is I had made the mistake of trying to add this sine over, but you cannot because there's multiplication here. And then my next thought was that because you have a sine and a sine, and there is multiplication here, that you would divide the sine by both sides, which would get you cosine x equals, well, you would divide by negative sine, which would get you 2. Unfortunately, you cannot do that because if we remember, sine is our y value, and sine, which is that y value, can be 0. And as we know, we cannot divide by 0. So therefore, what we have to do is we have to add this -2 sine onto both sides. So this gets us 0 on this side equals negative sine x cosine x plus 2 sine x. So now we can see that we have a sine here and a sine here, so we know that we can factor. And I'm going to factor out a sine x. So sine x negative cosine x. And then over here, because we factor out the sine, that leaves us with the cosine. Factor out a sine, that leaves us with a plus 2. So now we just have to set each of these equal to 0. So our solutions are going to be where sine x equals 0 and where negative cosine x plus 2 equals 0. So then we have to solve this, and that gets us negative cosine x equals -2, and then cosine x equals 2. Now, we know that there is no point on the unit circle where the x, which is the cosine, is equal to 2. So we know that this is not going to happen for us. We cannot do this, but we can find where sine equals 0. So if we look on our unit circle, we can find, we know our sine is our y value, so then we know that here at 360 or 0 degrees, our y is 0, and then here at pi, it is 0 as well. Okay, it is time for question 3, which is our difficult question for this part / section. As we see here, sine to the 4th x plus 2 sine to the 2nd x minus 3 equals 0. Now this may look very intimidating because you see a sine to the 4th, but fear not. It's not as hard as it seems. So again, we can think of this sine as an x, and what we're going to do, so then we would have x to the 4th plus 2x squared minus 3 equals 0. And then we can see to the 4th, we have to the 4th, and we have to the 2nd. So what we can do is we can kind of substitute and think, instead of a 4, it's going to be a 2. So x squared equals x. We can kind of substitute this idea in. Sorry, this is going to be a sine. We're substituting sine for x as well. So instead of sine, we can think of this as x squared plus 2x minus 3 equals 0. As you can see, if we plug this back in, x, which is actually x equals sine x. So sine x squared equals x, and then we can see if we factor this back in, it would go back to this form. So now that we have it here, this is a simple factoring problem, which we have x plus 3 and x minus 1, I believe, equals 0, because if we add those, we get 2, and if we multiply, we get -3. So now we solve, and we can actually plug the sine squared back in at this point. So now we have sine squared plus 3, and then sine squared minus 1, and then we have the x's here as well. Okay, so now we have this, and we know these factors are set equal to 0. And then what we do next is we take each individual one and then set that individual equal to 0. So we have sine squared x plus 3 equals 0. So now we are here. What we do is we subtract the 3 over to this side. So we have sine squared x equals -3. And then we have this squared here, and we want to get rid of that. So we square root. And then we know when we square root both sides, this side becomes plus or minus. We have sine x equals plus or minus. Oh boy, that does not work, does it? Because this is a -3, and we cannot square root a negative number because that gets us I, and unfortunately, there are no imaginary numbers on our unit circle, so this is dead. We don't care about it anymore. Okay, so we can move on to our next one though. Sine squared x minus 1 equals 0, add the 1. Sine squared x equals 1, square root. Sine x equals plus or minus because we're square rooting both sides, plus or minus, and the square root of 1 is 1. So all of our solutions are where the sine, which is our y value, as we know, is equal to a positive or a -1. So if we take a look at our unit circle, x, y, here's our y value, and you can see that this is 1, so 90 degrees is a solution. And then this is a -1, which is also a solution at 270 degrees.